we have seen in the previous video that rays can converge when passed through a lens so as to form a real image. And we also drew a kind of ray diagram to find the image, but just like in case of mirrors, we actually need a systematic way so as to find the image. So here in lenses as well, we have some special rays which we use while drawing a real image, while drawing ray diagrams. Okay, so let's see them one by one, and these are the special rays. So the first one is a ray that is falling parallel to the principal axis. And you know, by the definition of focus, these rays should pass through the focus in case of a convex lens, and by the definition of focus for a concave lens, it should diverge such that it's appearing from a point called focus. And this is true because this point is called the focus, and this point is called the focus. Okay, so the first point is clear. Ray parallel to the principal axis passes through the focus of the lens, and or it could be possible that it diverges as if it is appearing from the focus. And it's obvious that if the opposite happens, that is, a ray passes through the focus, it should actually move parallel to the principal axis after refraction. So we can say a ray that is passing through the focus, or something that is passing towards the focus after reflection, would travel parallel to the principal axis. Okay, so the next point says a ray that is falling onto the optic center will pass undeflected. And that is because if you see this case, you can see that this edge, the side where light is entering and the side where light is exiting, is actually making a triangular shape, right? And that's true everywhere. There is a triangular shape everywhere. But when it hits at the center, it's actually not hitting a triangle. It's hitting almost two plane surfaces, right? And so this part would act almost like a glass slab. So the light that is entering just exits parallel. Whereas here, it's not like a glass slab, it's like a glass triangle, which we will call a prism later on. So that's why the ray is getting deviated. Here, since it is hitting center, it won't get deviated. And that is our last point. A ray passing through the optic center travels undeviated even after refraction. Okay, so these are the special ray diagrams, and let's see some examples of using them to find the image. So the first one, let's consider an object placed beyond the 2f point. This is f, this is 2f, and we have to find where the image of this object would be. So in general, what we used to do is draw multiple rays, we find the point of convergence. But we know drawing many more rays is a waste. We just need 2 rays, and we'll use any 2 of those special rays. We can use one of them which is hitting parallel, and that is going to go through the focus. Okay, and the next ray could be a ray that is passing through the optic center, which goes undeflected, and we have a point of intersection, and that is where this point's image would be. So the image of the total object would be like this. Okay, and if you want, you can draw a ray that is passing through the focus as well, maybe like this, and that after reflection goes parallel, and you can see that also meets at this point. So you can take any of the 3 special rays. That's all. Okay, so this was the case for object beyond 2f, and let's see some other cases which we discussed in the activity. So this was object beyond 2f and image between f and 2f. Now let's see the object at infinity. So light coming from infinity are going to be parallel, as you know, and these parallel rays after refraction would pass through the focus. So the image would be formed at a focus, and no matter how big the object is, the image is going to be a point image that is highly diminished. And now let's see what happens if the object is at 2f. That is, we saw it at infinity, we saw it somewhere close, now we are going to this point. So with the object at that point, if you draw the ray diagram, you find that the image is also at the 2f, and it's also the same size as that of the object. So here in this case, the object was at 2f and the image was also at 2f, and the image is actually the same size as that of the object. So we can see a slight increase, right? So we can see that as the object comes closer and closer, the image is becoming larger. Initially it was smaller than the object, now it has become equal. And now let's come closer. Let's keep it somewhere between f and 2f. So with the object between f and 2f, we again draw the ray diagram. We draw two rays and they focus at a point beyond 2f, right? And the image is actually larger than the object. Okay, so for object at 2f, object between f and 2f, image is beyond 2f. Okay, now we go closer. We keep it at focus. So when the object is at focus, if you draw the ray diagram, you see that after refraction, the rays are emerging parallel. So since these rays coming out are parallel, if we extend it backwards, they will never meet. So we can say that the image is at infinity. Now let's see the next case. The next case is the object between f and o. And this is actually the position that we use to read and for most of our uses of a convex lens. And let's draw the ray diagram to find what it does. So we have taken two rays. One of the rays coming parallel and that passes through the focus, and one ray that is passing through the optic center which moves undeviated. So now if you were here and say this was one letter in the book, say this is a letter in the book, and suppose you were here and trying to read this, what would you see? So these rays would make you feel that this letter is not actually here, but the letter is here. And it would also make the letter appear big, right? So we see a bigger letter at a slightly farther distance. So this property of a lens to produce magnified but erect images is made use in convex lenses like reading lens. And this was the last condition that we saw in our activity. Here no real image is formed, a virtual image is formed at the same side of the mirror. Sorry, the same side of the lens. And so this was the discussion about the special rays and also image formation by lenses. All are actually repeated questions, I must say. So you can surely expect one of these questions in your exams.